Is flooding getting worse? In the last week of February 2022, parts of the UK experienced significant flooding following 3 named storms within 5 days of each other. A reminder of the impact weather can have on our lives and livelihoods. At the same time, communities across the world in Australia experienced devastating floods, and sadly a number of people tragically lost their lives. It's now accepted that the increase in greenhouse gas emissions from human activities is resulting in global climate change. Climate change is supercharging the water cycle's evaporation process and changing weather patterns, resulting in an increased frequency of extreme weather events and rainfall. An analysis of the wettest February on record for the UK, which occurred in 2020, concluded that the extreme rainfall experience was made about 3 times more likely due to climate change. A separate study of the flooding experience in Central Europe in July 2021 showed that climate change had increased the intensity of the daily maximum rainfall by up to 19%. Moisture content within the air is dependent on the temperature. For every 1 degree Celsius rise, the air can hold approximately 7% more water. According to the United Nations Environment Programme, UNEP, higher temperatures result in more cloud formation from surface evaporation. More clouds, which can hold more rain and correlate to a higher frequency, duration and intensity of precipitation and storm events. Climate change is amplifying the processes involved in storm formation, causing updrafts to grow stronger and wider, pulling in more warm air from surrounding regions, leading to more rain. These storms are essentially a tower of upward moving winds that feed themselves by sucking in warm air from nearby. When air rises high enough, it cools and condenses into rain. Experts predict storms and weather systems will intensify as the effects of climate change become more apparent, bringing as much as 50% more heavy rain to the UK by the end of this century. How will the UK be impacted? European-wide climate simulations of current and future weather patterns have spotted some warning signs about future weather and storm events. Scientists have found that extreme precipitation events are expected to increase most over the UK. The position of the Atlantic jet stream is expected to change, which will have significant knock-on effects to the weather experience within the UK and across Europe. The change arises because the Arctic is currently warming faster than areas at mid-latitudes, resulting in less of a temperature difference between the 2 regions. In response, the jet stream is expected to shift northwards in many simulations, bringing warm air from the mid-Atlantic behind it. The result is that the UK will see more severe storms throughout the year. The modelling also suggests that when dry spells occur, they will be much more prolonged. What other influences are there on flooding? Agricultural land use in rural upstream areas has a vital part to play in flood risk management. Upstream areas which were once covered in forests have been gradually lost due to intensive farming and deforestation, making the way for livestock grazing. The impact is that deforestation exacerbates the effect of flooding by increasing both the speed and amount of surface runoff, as well as decreasing the amount of rainfall intercepted. The health of soil is also dependent on the existence of trees. When deforestation occurs, the top layer of soil can be dislodged, known as soil erosion. When the top layer of soil is unstable, it is unable to retain any of the water that falls on it, resulting in increased surface runoff, in turn increasing the potential for flooding downstream. Deforestation also increases the risk of flooding indirectly. When deforestation occurs, the tree's capacity to take in carbon dioxide is removed. Carbon dioxide is the gas that continues to accumulate in the Earth's atmosphere and is a major contributor to warming global climates. As well as deforestation, flooding in urban areas is often caused by urban development itself. Impermeable areas such as roads and pavements significantly increases the speed of surface water runoff whilst hindering infiltration. This was highlighted in the significant surface water flooding in London of 2021. Urban drainage systems designed to manage and discharge this additional surface water runoff have been effective in the past. However, these urban drainage systems are now struggling to cope with the additional rainfall and surface water runoff of many urban areas. Their lack of effectiveness is often a combination of climate change causing more extreme precipitation, increased urbanisation and outdated infrastructure that's not able to cope with the new heavy rainfall experienced today. It's also not helped by the poor maintenance of drains and gullies, which often become blocked with debris following storm events. It should be noted, however, that engineering solutions cannot always provide solutions. Even the largest capacity drainage systems have the potential to be overwhelmed if the storm is significant enough. Flooding mechanisms are far more widely understood today than at any other time. It's known that climate change is significantly increasing the risk of flooding, while additionally land use plays a significant role. There are measures now in place to help mitigate the effects of flooding, forming a jigsaw of flood risk management, including elements such as sustainable urban drainage, natural flood management, planning regulations, anti-flood technology like self-closing air bricks, non-return valves, and of course property flood resilience. All these measures ensure the effects and impacts of flooding can be reduced and managed for future generations if we take action.